So much about Mendeleev's periodic table, how it looked like Mendeleev's periodic table. How it looked like Mendeleev's periodic table. So I have told you that it has got 8 groups. So it is 1, 2, 3, 4, 5, 6, 7, 8, 8 and 8. So there is trials about 8, 8 and 8. The groups 1 to 7, they are again subdivided into A and B. A and B. Alright, they are divided into A and B. Like this way it is divided into A and B. Now let us write a little bit about these elements. The first element which we have, that is hydrogen. At that time the inert gases were not discovered at the time of Mendeleev's, but the Mendeleev's periodic table, when the inert gases were discovered, we could just simply introduce one zero group and inert gases could be accommodated in that group comfortably. Alright, then after hydrogen we have lithium, then we have beryllium, then we have boron, we have carbon, then we have nitrogen, we have oxygen, alright, and we have fluorine. Alright, so like this way he arranged, and over here if you observe in the 5th group, over here now this becomes sodium, potassium, rubidium, cesium, this is beryllium, magnesium, calcium, strontium, barium and radium. So over here what I wanted to tell you is, over here comes copper, silver, gold. Alright, so now you can see what are the drawbacks. The first drawback is what? The position of hydrogen. Alright, if I write drawbacks over here, then the first drawback is, which is still prevailing, that is position of hydrogen. Position of hydrogen. Now over here as you can see, these are all metals. So hydrogen, it is a gas and it is being placed with these metals. So hydrogen should actually be placed with the halogens, that is fluorine, chlorine, bromine, iodine. It should be placed with these elements because it is a gas and this is forming -1 valency as well. So over here it is being placed with the metals because it is forming +1 valency. So similarly it is placed with the metals. So position of hydrogen is a question mark, that why position of hydrogen, it can fit into the group 1 as well as it can fit into group 7. Alright, now you can see that the elements such as copper, silver, gold, these are known as noble metals. They are not very reactive. But these elements, sodium, potassium, rubidium, cesium, they are very reactive metals. Now both these reactive and non-reactive metals, we are keeping them in under the same group, that is group 1. So this was a drawback, that why we are keeping these elements in the same group. Now as I have given you the example, that is cobalt and nickel, this is 56.9 and this is 56.1. Now if he is giving a law that the properties of elements are periodic function of their atomic masses. So that is atomic mass. Over here you can see the atomic mass of nickel is less than that of cobalt. So we should place nickel first and then we should place cobalt. So like this way you will find some more elements in the periodic table which are having this anomaly, and so Mendeleev's periodic table could not be obeyed for it. Now, besides this, you see we have isotopes. Isotopes. What are isotopes? You must have heard about it in your junior classes. Isotopes is the elements which are having the same atomic number but different atomic mass, such as carbon 12, carbon 13, carbon 14. So the atomic mass is different but atomic number is the same. So for such elements, if the elements are to be arranged according to the increasing order of their atomic mass, then each isotope should be getting a separate place, which was not feasible, which was not provided by Mendeleev. Alright, now let us write this in a tabular form, that what all anomalies were there. Alright, let us write anomalies of Mendeleev's periodic table. Anomalies of Mendeleev's periodic table. Alright, so first we have written that position of hydrogen was not justified. Was not justified because the properties of hydrogen were similar to the alkali metals, lithium, sodium, potassium, etc. These are electropositive. This will also form electropositive, as well as, since it is a gas at room temperature and forms H-1 ion also, it should be placed with halogens. It should be placed with halogens. Alright, it should be placed with halogens. Now second, that is no place for isotopes. No place for isotopes. For example, carbon 13 and carbon 14. So there is no place. Then third, some elements, for example, cobalt and nickel, are placed in a reverse order, of their atomic masses. Alright, of their increasing atomic masses. So the periodic law is not obeyed. Periodic law is not obeyed. Then we had also seen one more anomaly, that elements such as copper, silver, gold are placed under the reactive elements, for example, lithium, sodium, potassium, which is not justified. Which is not justified. Alright, which is not justified. So these elements, they are placed under the reactive elements. These are not reactive elements, but they are placed under the reactive elements such as lithium, sodium, potassium, and this is placed together under the same group, so this is not justified. Alright, now but you can see that Mendeleev's periodic table, it was a very good attempt to classify the elements. Now in modern era, that is what we call it as modern periodic table. Let us see what we are following. Modern periodic table. Alright, this was again given by a Russian scientist, that is Henry Moseley. Henry Moseley in 1917. Henry Moseley in 1917. Moseley की spelling मेरे ख्याल S-E. Alright, now let us see the modern periodic table. Let us see the modern periodic table. This was given by the Russian scientist, that is Henry Moseley, in the year 1913. Alright, Henry Moseley in the year 1913. Now, Henry Moseley, he studied this Mendeleev's drawbacks of Mendeleev's periodic table, and he just simple difference he made in the periodic law, that what he did. Now this periodic law, what he is given, we will call it as modern periodic law. Modern periodic law, that the properties of elements are a periodic function of their atomic numbers. Alright, now as you can see, if we are writing atomic number, then if I write carbon 12 and if I write carbon 13, then both carbon 12 and carbon 13, their atomic number is 6. So they can be placed in the same group. Alright, they can be placed in the same group. And if we are writing cobalt and nickel, so cobalt and nickel, they have got their own atomic numbers as such, their own different atomic numbers, and every time the atomic number is increasing by 1 when you are moving from left to right. So lithium, and then you have beryllium, so the difference in the atomic number is, this is 3, this is 4, and then this is 5. So every time you can see that the atomic number is increasing by 1. Over here also the difference is 1, over here also difference is 1, difference is 1. So like this way it is increasing by, every time the atomic number is increasing by 1. So he changed this periodic law, and he said that the properties of elements are a periodic function of their atomic numbers. Now how is the modern periodic table, how it looks like? Let us see. Alright, let us see that what are the characteristic features. We will write that characteristic features of modern periodic table. Characteristic features of modern periodic table. Alright, the modern periodic table, it consists of 18 groups. 18 groups numbered 1 to 18, numbered 1 to 18, and seven horizontal periods. 7 horizontal periods. All right. Now you know that the electrons are filled and we have the rule that is 2n square. So the first period, all right. So let us write over here, that is the first period is called very short period. All right, it is called very short period because it has only 2 elements. All right, let us write it in table form. That is the first period, it is called as very short period and number of elements is only 2. Number of elements is only 2. All right, so this is period number and this is name of the period, what we are calling, and this is number of elements. Alright, now period number 2. This is a short period. This is a short period and number of elements is 8. Then third, it is again a short period. This is also a short period and number of elements is 8 over here. Then we have a long, this is fourth period. This is fourth period. We have a long period and number of elements is 18 over here. Then you have fifth period. I am writing over here. You have fifth period and the fifth period is again a fifth period is known as again a long period and it has got again 18 elements. And then you have sixth period which is known as very long period. It has got 32 elements and seventh period is still incomplete. This is also a very long period and it has got 32 elements. Alright, now let us see over here very short period. See, if you are writing 2n square and the value of n is 1. So maximum capacity becomes equal to 2 into 1 square, that is 2. Alright, so number of elements is 2. If you are having 2 into 2 square, so the maximum capacity becomes equal to 8. So this is a short period. If you have 2 into 3 square, so maximum capacity becomes equal to 18. But we know that outermost orbit can have a maximum of 8 electrons. So we are having 8 electrons over here. Alright, similarly for the long period, this is 4 fours are 16, 16 plus 2, 18. So yes, we have got 18 electrons over 18 elements over here, and similarly we have, this is also a long period. This is known as very long period. So we have got from this what you can understand, that this period number is signifying what? Period number is signifying the number of shells. Alright, period number is signifying the number of shells. So it consists of 18 groups and it consists of 7 periods. The modern periodic table, it consists of 7 periods and 18 groups. Alright, now we will also be writing that the group number signifies the number of valence electrons while the period number signifies the number of shells. Period number signifies the number of shells. Say supposing if I write that I have got potassium 19 and I have to describe that to which period it is belonging and to which group it is belonging. Alright, to which period it is belonging and to which group it is belonging. So I will write the electronic configuration of potassium. How do I write? You know that this is 2, first this thing K shell, then it is 8, 2, 8, and then it is again 8, and then it is 1. Alright, 2, 8, 8, and then 1. Configuration of potassium. So over here, since the outermost valency over here, number of valence electron is 1 over here, so the group will be over here, it will be group 1. And since it is how many shells it has got? 1, 2, 3, 4. So this will belong to the 4th period and it will belong to, this element will belong to group 1. Alright, so that is the group number. We will say that the group number signifies the number of valence electron. We can see for some more elements like this way. Say supposing if I write calcium, 20, all right, or if I write calcium will be just calcium 20. All right, first let us see for calcium 20. Then over here what I can write, the configuration will become 2, 8, 8 and 2. So number of valence electron is 2. That means the group over here will be 2, and since the number of shells is 4, so period will be equal to the 4th period. Alright, so the period number signifies the number of shells and the group number signifies the number of electrons to which it is placed. Alright, now let us see, there is another term which we will call it as valency. Valency just now we are seeing, that is, let us see some more terms over here. So and some groups which we are seeing. All right, so that is group 1 को हम लोग क्या कहते हैं? Group 1 को हम लोग कहते हैं alkali metals. सारे के सारे metals है, हाइड्रोजन को छोड़ के they are all metals, तो हम लोग इसको कहते हैं alkali metals. Group 2 को हम लोग कहते हैं alkali earth metals, क्योंकि ये भी एल्कली बनाते हैं, इनकी ऑक्साइड्स भी सोल्यूबल है, प्लस ये अर्थ में बहुत लार्ज क्वांटिटी में दे आर फाउंड ऑन द अर्थ, सो वी कॉल इट एज एल्कली अर्थ मेटल्स. ऑलराइट, वी कॉल देम एज एल्कली अर्थ मेटल्स. ऑलराइट, देन इसके बाद आ जाता है ग्रुप 16. ग्रुप 16 का मतलब हो जाता है ऑक्सीजन की फैमिली. ठीक है, ऑक्सीजन की फैमिली, ऑक्सीजन सल्फर, सिलीनियम, टेलुरियम, पोलोनियम, ऑक्सीजन फैमिली, इसको हम लोग कहते हैं चैल्कोजेंस. चैल्कोजेंस. फिर आ जाता है ग्रुप 17, इसको हम लोग कहते हैं जो फ्लोरीन, क्लोरीन, ब्रोमीन, आयोडीन, इसको हम लोग कहते हैं हैलोजेंस. वी कैन राइट इट एज fluorine family. All right, fluorine family. So this is known as halogens. Then group 18, this is all the inert gases. All right, so that is helium, neon, argon, krypton, xenon and radon. These are known as the inert gases. These are known as inert gases. Alright, these are known as inert gases. So these groups, you should remember the names of these groups, what these groups are known as, and you should also remember that the first period is a very short period, second and third period, they are short periods, and after that fourth and fifth, they are long periods, and sixth and seventh are known as very long periods. Now let us see some periodic properties. Alright, let us see some periodic properties. What do we mean by periodic properties? Periodic properties. Now, periodic properties, how it is periodic properties? That is, the first property is valency. Alright, the first property is valency. See, modern periodic table, if you look at the modern periodic table, how it looks like, it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 and 18. Alright, then how it is made, that is, in the first period we have got only two elements, so that is, one is hydrogen over here, and in the 18 group you have helium over here. Alright, you have helium over here. In the second period you have from lithium, beryllium, boron, you have lithium, then you have beryllium, and then after this 10 groups, leaving this 10 groups, then after that over here the electron will fill over here, then you have boron, then you have carbon and nitrogen, oxygen, fluorine, and you have neon over here. This is second period. Then in the third period it begins from sodium, then beryllium, then over here you have magnesium, and over here you have again aluminium, below carbon you have सिलिकॉन, नाइट्रोजन के नीचे यू हैव फॉस्फोरस, सल्फर, क्लोरीन, और नियॉन के नीचे यू हैव argon over here. Alright, so you can see there are two elements, very short period, then you have 8 elements, again you have 8 elements, और उसके बाद जो फोर्थ पीरियड आएगी, फोर्थ पीरियड दैट इज पोटेशियम, और ये आ गया कैल्शियम, उसके बाद ये थर्ड में भरेगा, दैट इज स्कैंडियम, टाइटेनियम, वेनेडियम, क्रोमियम, मैंगनीज, इस तरीके से ये भरना इसमें शुरू होगा. ठीक है, सो दैट इज, लेट अस राइट स्कैंडियम, टाइटेनियम, वेनेडियम, क्रोमियम, मैंगनीज, देन यू हैव आयरन, कोबाल्ट, निकल, कॉपर, जिंक, और बोरॉन, एल्यूमिनियम के नीचे आ गया गैलियम, और कार्बन, सिलिकॉन के नीचे आ गया जर्मेनियम, नाइट्रोजन, फास्फोरस के नीचे आ जाएगा आर्सेनिक, ऑक्सीजन और सल्फर के नीचे आ जाएगा ऑक्सीजन, सल्फर, सेलेनियम, और फ्लोरीन, क्लोरीन के नीचे आ जाएगा ब्रोमीन, और ये नियॉन, आर्गन के नीचे आ जाएगा क्रिप्टन. ऑलराइट, सो ये हो जाएगा हमारा 18 एलिमेंट्स. ठीक है, तो आपको ये बीच वाला इतना याद करने की जरूरत नहीं है एट क्लास 10 लेवल. सो दैट इज, से फॉर योर रिमेम्बरेंस, से आप लोगों को एक अगर जिस्ट सा बना के दिया जाता है पीरियोडिक टेबल, तो आपको क्या दिया जाता है कि फर्स्ट पीरियड में 2 एलिमेंट्स हैं, सेकंड और थर्ड पीरियड में ये बीच वाला खाली है, थर्ड, फोर्थ, फिफ्थ, ये 12 तक खाली है. नेक्स्ट एलिमेंट कहाँ से फिल कर रहा है, दैट इज फ्रॉम ग्रुप 13 से फिल कर रहा है. 1, 2 के बाद ग्रुप 13 से फिल कर रहा है. अगेन थर्ड पीरियड में भी 1, 2 फिल करने के बाद फिर 13 से नेक्स्ट एलिमेंट फिल कर रहा है. एंड देन व्हेन यू कम इन द पीरियड 4, देन ऑल दीज 3 से लेकर के 12 ये ग्रुप 4 में भरना शुरू होता है. Alright, now we were discussing about the periodic properties. Let us write periodic properties again. Periodic properties, और periodic properties में आप क्या देखोगे, सबसे पहली प्रॉपर्टी हमने देखी, क्या देखी, वेलेंसी की. ठीक है. So valency is the combining capacity of an element, that is the number of electrons exchanged in a given reaction. गिवन रिएक्शन में कितने नंबर ऑफ इलेक्ट्रॉन्स हैव बीन चेंज्ड, ये उस एलिमेंट की हो जाती है वैलेंसी. ठीक है. सो दैट इज ग्रुप नंबर. ठीक है. सो फॉर ग्रुप्स 1 and 2, all right, for groups 1 and 2, the group number signifies its valency. Group number signifies its valency. ठीक है. For group 1 and 2, the group number signifies its valency. Then for groups 13 to 18, 13 to 17, if we write group 13 to 17, then it is the valency is equal to group number minus 10. Group number minus 10. So say supposing if I write that boron is in group 13, then its valency is equal to 13 minus 10, that is its valency is equal to 3. So we will not write that its valency is equal to 13, its valency is equal to 3. So group 13 to 17, the valency is equal to group number minus 10. And then these groups, say supposing in between, that is from group 3 to 12, these are known as transition metals, and they have variable valencies. They have variable valencies. All right. And again, the last one, group 18, which is inert gases. Inert gases. For them, the valency is 0 because they will not react. So the valency is 0 over here. Only some inert gases such as xenon, etc., they will form some compounds, but otherwise for inert gases they are not reactive. So the valency is 0 over here. Alright, now this was about valency. Now let us see the trend in valency. Alright, now let us see the trend in valency, how it is moving. Alright, so from I am beginning, that is group 1, 2, and then after that I am writing group 13, 14, 15, 16, 17 and 18. Alright, say supposing if I am writing for the second period elements, if I am writing their hydrides, so how I will write, this is LiH, this becomes BeH2, this becomes BH3, this becomes CH4, this becomes NH3, and this becomes H2O, and this becomes HF, and this is of course neon, which will not form any hydride as such. So you can see the valency. If I observe over here the valency of lithium, over here the valency is +1. For beryllium the valency is +2. For boron the valency is +3. For carbon the valency is +4. Then after that, now it is decreasing. Alright, now it is decreasing. Now the valency will become, for nitrogen, this will become, the valency will become 3. And for oxygen, now it is combining it with 2 hydrogen, so its valency is decreasing. Its valency is decreasing to 2. Similarly, for fluorine, the valency is decreased and this becomes now minus. So this becomes, the charge becomes minus. This is -3, -2, -1, and this is not forming, so this is becoming oxide. So what you can observe is that valency increases up to 4 and then again the valency decreases to 0. Alright, along the period the valency increases up to 4 and then again decreases to 0. So if you move down the group, then down the group means if lithium is having like this way, similarly sodium hydride, if you write, sodium will also be having the valency 1. So we can write in a nutshell that along the period the valency increases up to 4 plus 4 rather, up to plus 4 and then again decreases to 0. Alright, and down the group all the elements have the same valency. All the elements have same valency except a little bit which you will be studying in your higher classes, not at this level. So down the group all the elements will have same valency. If it is CH4, then this will be down the group, it will be having SiH4. So the valency will be 4 for silicon also, it will be 4 for carbon also. Alright, now let us see another property which we call it as atomic size. Atomic size. Alright, atomic size. And how do we define atomic size? Atomic size, it is the distance between the center of nucleus and the outermost shell of an atom. Alright, so it is that is the radius, what we say, we can say atomic radii is only taken as the atomic size. And if it is an ion means it can be a cation or an anion. So if it is an ion, then for the ion also we will do the same thing, that is from the distance from the center of the nucleus to the outermost shell is known as the atomic size or ionic size. Alright, so this is the distance. Now you see what will happen along the period, what it should happen. Along the period what we are observing, that if the electron is filling up in the second shell, alright, if the electron is filling, if it is for lithium, then for lithium what do we have? Inside the K shell will be having 2 electrons and outermost shell will be having, for lithium it is having 1 electron. Alright, then after lithium if we write sodium, then for sodium we have that there are 8 electrons are already filled over here. 1, 2, 3, 4, 5, 6, 7, 8. This is already filled and now a new shell begins and there is 1 electron over here for sodium. Alright, so along the period, if we are moving along the period, let us see. Along the period, let me write. along the period, if I am writing, say supposing if I am writing for lithium, then the configuration of lithium is 2 and 1. Then if I am writing for beryllium, then the configuration is 2 and 2. For boron, the configuration is 2 and 3. Similarly, for carbon, the configuration is 2 and 4. For nitrogen, it is 2 and 5. Oxygen, it is 2 and 6. For fluorine, it is 2 and 7. And finally for neon, it is 2 and, sorry, this is 2 and this is 2 and 8. Alright, 2 and 8. So, say what I am observing is I am moving in the same period. This is all second period elements. Alright, this is all second period elements. So, when I am moving in the along the period, what is happening? Every time the electron is entering the same shell. Electron is entering the same shell. One electron is entering this shell and another one proton is also entering the nucleus. So what happens? Now the nucleus is becoming very strong. So it is able to pull the outermost electrons more strongly. So as a result, what will happen? The atomic size will decrease. So along the period, what I can write that atomic size decreases. Why it decreases? Because the nuclear attractive force increases. Alright, nuclear attractive force increases. So the nuclear attractive force is increasing. Nuclear attractive force increases because the electrons are entering the same shell. Since the electrons are entering the same shell. Alright, electrons are entering the same shell. Now down the group, what will happen down the group? Down the group, you know, every time one new shell is being added, although the nucleus is becoming stronger, but since new shell is being added, so what will happen? When a new shell is being added, so the size will increase down the group. Since with the beginning of each period, a new shell adds on. Therefore, a new shell adds on. Therefore, the size will increase. Alright, size will increase. So along the period, atomic size decreases, and down the group, the atomic size increases. Very good. Alright, now say supposing we have seen that along the period, the atomic size decreases. So if you write from lithium, if you are given simply that lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon, then you will write that the size of lithium is largest, beryllium is over here, and it is like this way. Alright, but there is a little bit of anomaly when you come in fluorine and neon. A little bit of anomaly, that is the size of neon is larger than that of fluorine. Why? Because the neon is having a complete completely filled shell, and in neon, in this inert gases, there will be electron repulsion, and this electron repulsion will pull the electrons outside, and so the size increases. So a size will increase a little bit when you move from fluorine to neon. Fine. Now after this atomic size, now let us come to another property which we known as electropositive character. Electropositive character, or we may also call it as metallic character. Alright. So metallic character, what this metallic character is? Metallic character, this is determined by the ease of giving electrons. Ease of giving electrons. So electropositive character, electrons are given, means the ion now becomes a positive ion, it becomes a cation. So this is determined by ease of giving electrons. Alright, now let us see, say if we are looking at the elements which are on the left side of the periodic table, say supposing if we are writing the configuration of lithium once again. So lithium is, we have seen it is 2 and 1, beryllium it is 2 and 2, boron it is 2 and 3, and carbon is 2 and 4, nitrogen is 2 and 5, and oxygen is 2 and 6, fluorine is 2 and 7, neon is 2 and 8. So see over here, that is when 1, 2 or 3 electrons are present. Now it is easy to remove 1, 2 and 3 electrons. So that is, we can say that in the left side of the period there is electropositive character, and now when the number of electron becomes large, then it becomes difficult to pull these electrons. Now these elements, they can complete their octet by just gaining a few electrons. So this, of course, carbon will share 4 electrons and nitrogen will gain 3 electrons. It will become N3 minus. Similarly, oxygen will gain 2 electrons and this will become O2 minus. This will gain 1 electron and this will become F minus, and for this is already the octet is completed. Alright, so what we can write, that this electropositive character, if we are writing, then the electropositive character or the metallic character decreases as we move along the period, all right. And this electropositive character, as we are moving down the group, what will happen? This electron, this is becoming farther from the nucleus, so it will become easier to pull these electrons. So down the group, what will happen? Down the group, since the nuclear attractive force is decreasing, therefore electropositive character increases. All right. So we understand that, first of all, what is electropositive character? Electropositive character means the ease by which an element can lose electron, and along the period, when you move along the period, then electropositive decreases. Electropositive decreases along the period means what we can say, that non-metallic character increases. Alright, along the period, non-metallic character increases, and down the group, the ease of giving electron increases. So the electropositive character also increases, or we may say that metallic character increases. Metallic character increases down the group. Metallic character increases down the group. Alright, now we will come to the last property, that is electronegativity. Electronegativity. Alright, now what is electronegativity? First, let us learn about what is electronegativity. So we have learned in our previous chapter about covalent bonds. Alright, covalent bonds, that is, they are formed by sharing of electrons. Now if A and B, they have shared their electrons and they have formed this covalent bond. Now say, supposing B is more electronegative, these electrons, they should be lying somewhere in the middle. That is, they should be equally shared, since each element has contributed one electron. So these electrons, they should be shared equally by these two elements. Now say, supposing that B is more electronegative, so what it will do, it will pull these shared pair of electron more towards itself, and there will be a partial negative charge on B and partial positive charge on A. Alright, partial negative charge on B and partial positive charge on A. So partial positive charge on A. So such tendency to pull the shared pair of electron towards itself is known as electronegativity. What we can write, that is, tendency to pull the shared pair of electron towards itself is known as electronegativity. This is known as electronegativity. Now let us see the trend of electronegativity. What trend it has got? Trend of electronegativity. Trend of electronegativity along the period. Along the period, what will happen? Electronegativity increases. Why it will increase? Because atomic size decreases and nuclear attractive force increases. Alright, nuclear attractive force increases. So along the period, electronegativity increases, and down the group, it will be just the opposite. Down the group, what happens? That atomic size increases and nuclear attractive force is not so strong. Alright, therefore electronegativity decreases down the group. Down the group, the electronegativity decreases down the group. Alright, so with this, I think this chapter is over for you. Thank you, students. Thank you very much. Alright, students, so we have seen the metallic and non-metallic character. Now you know that the metals, metallic oxides, they are basic in nature, and non-metallic oxides are acidic in nature. So let us write one topic, that is nature of oxides. Nature of oxides, how it varies. Alright, nature of oxides, and let us see, that is nature of oxides. What will, since the left side of the period is metallic, right side is non-metallic. So what it is, we will write that along the period what will happen? Along the period, the nature of oxides, nature of oxide changes from basic to amphoteric and then to acidic. Alright, let us see how it is. Say for the third period oxides, what it is, we have the first element, that is sodium oxide. Then after that we have beryllium, magnesium, we have magnesium oxide. Then after that we have Al2O3, and then we have SiO2, then we have below nitrogen we have phosphorus, that is P2O5, and we have after that below oxygen we have sulfur, that is SO2, and then below fluorine we have chlorine, that is Cl2O7. Now let us see what are the nature of these oxides. Alright, so this is highly basic. This is alright basic, not so very highly basic, but this is also a basic oxide. Aluminium, what type of oxide it is? It is amphoteric. This will react, we must have seen it in the acid and bases chapter, even in the metal chapter, that this will react with metals as well as this will react with acids as well as with bases. Now SiO2, this is a weakly acidic. This is weakly acidic, and this is again, this is acidic, and this is a strong acid. This will, when dissolved in water, this will form H2SO3, which is a strong acid, and Cl2O7, this is a very strong acid. So you can observe, that is the nature of the oxide. It changes from basic to amphoteric and then to acidic. From basic, that is from highly basic, it is changing, it is becoming amphoteric, and then finally it is becoming acidic. So yes, so this was about the nature of oxides.